In this video, I'm going to be going over questions that are similar to those questions that students will see in the Module 5 DBA. This first one asks us to draw a dot plot for the data set. So a dot plot just takes the data and counts up how many of each kind, or you can make bins as well, but I'm just going to make a dot plot here where we go 6, 7, 8, 9, 10, 11, 12, 13. So I didn't put all the numbers in there, but that should be good. And then we just put how many dots there are there. So there's one data point here that it has a value of 6. So 1, 6. 1, 2 sevens. 1, 2. 1, 2, 3 eights. 1, 2, 3. 1, 2, 3, 4, 5, 6 nines. 1, 2, 3, 4, 5, 6. And notice I try to keep the spacing pretty similar there. Two tens. 1, 2, and a 13. So there is the dot plot for number 1. Here we're supposed to draw a histogram. Now histograms are quite a bit like dot plots, but instead of having a dot, they have a box that we're filling in, so a bar, another way of saying that. So let's see. I see that our minimum value is 74.2 here. These are in order. That's nice. Our maximum value is 82.5. So I'm going to go by ones again on my histogram down here. So we're going to start here at 74, and then we'll have 75, 76, 77, 78, 79, 80, 81, 82, 83. And over here on the side, we're going to count up how many of each there are. So between 74 and 75, we just have the 1. So we fill in like this. I'm going to use blue here. So that's how we show that. And you don't have to fill it in. You can leave it empty if you want. The next data point here that we have is these two, 78.3 and 78.4. So if here's 77, then here's 78. So between 78 and 79, we have these two data points right there. So this goes up to 2, just like that. I'm not going to worry about coloring them in. The next one we have is the 79.3, so that's going to be between 79 and 80, so here. And there's only one value in that bin, or that range. Then between 80 and 81, we have 1, 2, 3. So that's going to go up to 3. We have one that's exactly on 82 here. So we're going to put those two in the same bin. So usually you go above 80. So because this is 82 and above for this bin right here. So that's where that's going to fall in. Just going to go over there like that. So that is our histogram for this data. Box and whisker plot. The first thing we're going to want to do here is organize the data from smallest to largest. We have 1, 1, and then we have 1, 2, 3, 4 twos. 1, 2, 3, 4. We have 2 threes, 2 4s, and 2 5s. So that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. Since there are 11 data points, if we have these 5 and those 5, that leaves the middle one, the number 6 data point here, is our median. So this is the median. And that's important because then that allows us to identify that from these, we can find the middle one of those. There are 5 data points. So here's 2, there's 2. The middle one of those is going to be our Q1. Similarly, we take these 5 data points, and the one in the middle of those is the Q3. So now we have our minimum data point, Q1, the median, Q3, our maximum. And we can draw that box plot. So I usually start drawing the median. That's useful. It seems helpful to me. The Q1 is just has the number 2, and Q3 has the number 4. So those should be pretty similar distances away from each other, since they actually do represent 1 unit away from the median. And that's going to be the middle, the box of our box and whisker plot. Our minimum data point of 1, about the same distance away. Our maximum data point of 5, about the same. Well, they all should be exactly the same distance away, but I'm not exact. I can't do that. So there you go. That is our box and whisker plot for this data. And now we're looking at the mean. So when we're calculating the mean of data, we add all the data together and then divide by however many data points there are. So what I'm going to do is I'm going to bring a calculator in here so that I can add these data points up. So 1,815, and add to that 1,625, and add to that 1,795. Keep going. 1,365, 1,550, 1,315, 1,655. Hopefully I'm getting all these in there correctly. 1,370, 1,715, and 1,790. And now I can just hit enter on those. And the result then is, so when I add all those together, I get 15,995. And I'm going to divide by however many data points there are. There are 10 data points. So when I do that division, I can just go in here and say divided by 10. And the result is 1,599.5. And that is the mean, or the x bar. That's one way we write it. The x bar, or the mean. Same thing. And that is in kilograms. So on average, a car weighs 1,599.5 kilograms. Here we're going to find the interquartile range. So that involves basically almost making a box plot. We don't have to, and here's why. So we can order the data. Sorry about that. 3 is the smallest, and then 5, 1, 2, 3. 1, 2, 3. Then 7, 1, 2, 3. Then 9. Then 11. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, makes it so easy. So the in the sense that when they're an even number, then you have to change things up a little bit. And we'll actually see that with the quartiles. So here is the median. And then if we look at these 4, our quartile, first quartile, is going to be the average of these two because we have 4 data points. And to find the middle data point of those, well, there is no middle data point, so you add them together, these two right here, and then divide by however many data points there are, and that's 2, so 10 divided by 2 is 5. Now, similarly, we have to take these 4 data points, and since these two are in the middle, our Q3 is going to be 7 plus 9 divided by 2, which is 16 divided by 2, which is 8. Now, the interquartile range is calculated as Q3, our third quartile, minus Q1, our first quartile. And in this case, it's going to be 8 minus 5, which is 3. And that is our answer, the interquartile range. Here, the number of pieces of candy in a large candy jar is normally distributed with a mean of 500 and a standard deviation of 50. Which of the following is closest to the percentage of jars that contain between 450 and 550 pieces of candy? What that really should say is just what percentage of jars contain between 450 and 550 pieces of candy. Sorry about that. So I usually draw out, just sketch the normal distribution. In the middle, that's the mean. So the mean here is 500, it says. And when we look at a normal distribution, our first standard deviation, so that's one standard deviation away from the mean, we take the mean and we subtract the standard deviation to get this lower boundary. And then we take the mean and add the standard deviation to get this upper boundary. And that's one standard deviation. Then we go out 2 standard deviations like that and continue on that same pattern. And we just add 50 as we move out to the right because that's our standard deviation. Subtract 50 as we move out to the left. And what we might remember is that within 1 standard deviation, that's 68%. Within 2 standard deviations, that's 95%. And within 3 standard deviations, that's 99.7%. So in this case, we're looking at between 450 and 550, like that. And so that's going to be 68% of all of the data. Here we're going to draw a box and whisker plot. Ooh, and this one's, we got to really do some work on this one. The data's not in order and it's kind of big data, so it's a little bit of a mess. So we have 212,237 right there. 236,123. 259,841. 285,068. The next smallest one appears to be this 347,483, 396,815, 601,222, and 731,424. All right, so we have a total of 8 data points. And so that means that in order to find the median has to be an average of the middle 2 data points. So it's going to be an average of those 2 data points right there. So we're going to take the 285,068. We're going to add to that the 347,483. And then we're going to divide the result by 2. All right, let's bring that calculator back in. Whoops. And So we have a 285, 068, and we're going to add to that the 347, 483, and that will give us 632,551, and I'm just going to divide by 2 right now since I'm here on the calculator. So that's going to equal 316,275.5. And that will be our median. So I'm going to put this right in the middle here. 316,275.5. And so now I can take the bottom half of our data to find the first quartile, and it's going to have to be another average. So it's going to be the 236, 123 plus the 259, 841. Divide that by 2. And I'm going to set up this Q3 as well at the same time. That's going to be the 396, 815 plus 601, 222. Divide all that by 2. And so let's see what we get when we do that math. So 236, 123 plus 259, 841. We're going to divide that by 2. And that's going to be 247,792. And the next one is 396, 815. And we're going to add to that 601, 222. And that's going to be that, and we're going to divide by 2. And we'll get 499,018.5. All right. So I'm going to just kind of estimate here. Well, let's see. Our smallest, our smallest value here is going to be 212, 237. And then at 247, that's going to be about right there. That's 247, 792. That's our Q1. And then at 499, maybe there, 499, 18.5. That will be our Q3. And then way, way out here at 731, 424 is our maximum value. So it looks like that. This maybe should be moved over a little bit to the left. Something like that. But I think that's not bad. Looks pretty close to accurate. All right. And construct a scatter plot. So we're just going to take these. Whoa. I hope you're able to see that last one. We're going to take these and plot them. So an x value of 40, a y value of 2,200. Right about right there. These are just, I'm putting them on there as close as I can. X value 250, y value 3,700. $320, 4,500. 560, 5,900. 660, 7,300. 810, 8,600. 870, 8,600. 880, 9,200. 980, 9,700, and 1,000, 10,200. All right, so there's that, and it says, is there a positive, negative, or no correlation? Well, these are going up from left to right, and that is a positive correlation. It's a pretty strong positive correlation too, because all of the points were pretty close to a single line that we could draw through them. So it's a pretty strong positive correlation. And that is the last question here. I hope that you find this to be a helpful video. Take care. Good luck. Have a good day.